All right. Hi. Good evening once more, or good afternoon once again. My name is Erwin Williams, and you cannot see me, but you can definitely hear me, I hope. And this is the beginning of the third episode of Teleios Power Hour Live. Uh, when I reveal the camera, you still won't see me. You'll actually see something pretty cool. What you'll see is a little setup we created today. You'll also see Akash. The guy behind there is Akash. Akash, you could wave if you'd like, but you don't have to. It's entirely up to you. But in our foreground is a breadboard and some circuitry and what looks like a LED. Is it actually a breadboard, Keisha? Would you call it a breadboard or just a board? Right, good. So it's a breadboard and there's a circuit on it, and you can also see what should appear to be an LED bulb. Let me turn it a bit so you can see more of what's going on with this bulb. So you should see that it has 4 wires coming out of it and a lot more business happening with that circuit. Let me turn it up like so. So you can also see this light indicates it's on, this LED, and this cord here is for power. This device is a particle or a spark core. There's a company called Teleios, and they make these devices. They're really good for IoT or Internet of Things projects. Generally, IoT is that term used to describe those technologies where you have sensors or devices out in the field or out in the real world, and they communicate via networks to some central server, or they receive feedback from those servers. I see Ryan just joined us. Yeah, Ryan, I'm talking. Probably can't even see that. Sorry. So back to Spark Core. It's built by a company called Teleios. They build a few other devices, and they're really good for projects where you want to provide internet-based programming to sensors and devices that could then be reprogrammed by the internet. This one, the Spark Core, has a Wi-Fi module together with a processor on it that it could receive instructions over Wi-Fi and then provide directions to, in this case, a light bulb, or it could be any sensor or any other equipment attached to the board. So what are we using it for? Well, I can show you quickly how it works. Let me share my screen, and you'll see some code from Teleios. So if you're familiar with Arduino development, Arduino allows you to write code in C++, and you can use that to issue commands to these processors. Since I'm using Particle and their Spark Core, I'm writing these commands, almost the same commands you write to Arduinos, except it's being written on the web. And once I write it here, and I choose to flash, if the code compiles, it'll then send it down to the core. This is a very simple Particle Spark Core project. It literally lets you blink an LED via commands issued on the internet. So very, very straightforward. Typically, if you're using the core, there's a loop function that you'd put stuff in and that runs every X period or runs based on some schedule. Alternatively, you can have functions. So you can leave loop without any commands, and you could have functions available online. So this particular function, LED toggle, receives commands and it issues them to the core. There are a few others. They allow you to go through those commands and do useful things with them. I have one here that uses the loop to simply turn a LED on and then turn it off and wait for a while. These delays are in milliseconds, and then carry on again. So quite a few functions. For the one we're using today, it uses that LED we saw with four wires coming out of it in a special way. First of all, that LED is not just a regular one. The regular ones we know of may have one color. When I was talking to Russell about this, he said, well, yes, it's nothing more than a Christmas light, though, and it's a waste of time. This one is a little different because with Christmas lights, those bulbs tend to just be one color. And so you may be familiar with one color, single color LEDs. You also have the RGB LEDs, which lets you essentially turn on red, green, or blue based on what you write or what command you send to your core. So you can see here this code starts off initializing those pins, and in a little while we'll talk about what D0, D1, A, and so forth are. And then you set it up. Oh, I'm sorry, my font is pretty low. Let me turn this up. That should be better. Thanks, Ryan. So you can see the pins being set up. Here they go. We go ahead and via the Spark core, we tell them these pins will receive output as opposed to providing input. And just under here, you can see from lines 30 to 33, we essentially turn all the LEDs off by issuing telling the Spark core to send a low signal to each pin. In between there, on line 26, you can see we're setting up a function that's identified by LED and actually will have commands managing this other function called LED toggle. So I said loop, nothing to see, we're not doing anything in loop. This is going to be very quick. Here we can see when you invoke LED toggle, you can pass a command to it. And based on that command, we will indicate which LED which color will turn on. You can go with red, green, blue, or all. So let me show you how I can actually invoke this. So this is essentially our code for the core. Let's take a look at this is PowerShell, and we use it to script a bunch of stuff here anyway. And I'm gonna use this PowerShell script to quickly turn that light on and off. Take a look at it. Notice it's going to have a URI, and it's going to say invoke this URI with a HTTP post and set the argument to green or red. I'm going to do it down here. So let's just stop screen sharing and take us back to the camera. So you should see the camera and again see Akash. So now, the method that I'm using, I'm going to say in this LED green. So I just issue the command and it's green here, but it looks white on camera. I'm sorry. Let's make it red and see if that looks better. Right. So at least a color changed. It's not very clear on the camera, but trust me, the color's changed. And then I can take it off. So let me ask the audience, what would we use this for? Those of you who know what I'm going to do with it, don't say that thing. Say something else. What would you use this kind of stuff for? We'd probably go with Christmas lights to start us off. Right, so Ryan is saying if the build failed. Yeah, sounds good. What else, guys?
You could use it for Falcon Watch.
Well, what kind of women say, Akash, what's Falcon Watch?
So Falcon Watch is an application that we use to monitor the Falcons. So I guess you explain what the Falcons are.
So, so everyone, Teleios has a very interesting and very useful code for describing products when they're in development. So you may know of QuickWorks or the Teleios Message Central solution or Match Dominator. But internally, when the products get started, we need to have some way of identifying them while the product team themselves come up with the actual product in its full concept, and they document what they wanted to do and that kind of thing. So very, very simply, we use colors and animals to identify curious products. So the falcons Akash is referring to, we have one called red falcon and one called white falcon. They both maintain connections to providers, and we often need to know how those connections are doing. So our another program, helper program that provides heartbeat functionality, essentially letting us know anything is still running. So it sends out messages. It sometimes makes noises like a falcon. So Falcon Watch would go caw caw if there's a problem that can't be fixed. True story. This light seems like it could play a similar functionality. So what else could we do with it?
You need to read the chat, even. There are a lot of suggestions in the chat.
Oh, I'm seeing. Oh, Ram, meetings in progress on Skype with the status. Oh, sorry. That's pretty cool. Yeah. So what? I guess a meeting room will have a light on that kind of showing meeting in progress as based on the calendar entries. Good. That sounds good. I like the one from Niall saying, make it even more focused if you have meetings with clients. Keep quiet downstairs, because of course downstairs could get raucous and rowdy while we're trying to figure out what caused that particular error. And Nikhil is rounding us up by saying, signal the start of power hour by using a light that blinks throughout the office. Thanks Darren, I like that one, temperature sensors. So definitely you can use you could go forward this, which is why the Internet of Things is a big deal and continues to attract a lot of interest. So let's take Ryan's suggestion further. So Ryan is saying, what if we could go ahead and indicate if builds are successful or not, based on using a light like this? All right. As it so would happen, I kind of have a build set up for that purpose. So let's screen share once more. And while I'm doing that, we're developing and continuing to enhance our own build process here at Teleios. So I'll ask Russell to kind of start us off and share with us what that means when we talk about the build process. Russell is the product manager of Teleios' QuickWorks. Russell, can you describe really our build process, at least the start of it for these guys while I set up this example?
Yeah, sure, no problem, Owen. All right, so the build process for any particular feature that goes into QuickWorks starts off with a concept or an idea. So we have a product management team who sits down multiple times a week, and we come up with what the vision for QuickWorks are. We look at the market with respect to the technologies that we use in QuickWorks, the technologies that QuickWorks runs on, and we come up with these cool features that we would like to be implemented in the product. Once we have a good idea of where we want to go with the product, we then start to identify particular features and dive very, very deep into that particular feature. So we start identifying requirements for that feature. We start identifying how the user should use the particular feature, and we create something what is called a PBI, or a product backlog item, which Owen is showing right now on the screen. That product backlog item basically represents a feature or part of a feature which is to be implemented in the product. We define that as much as possible, because we would not know everything at the start when we are defining the feature. And then we engage other individuals like our user experience team, our developers, our testers to give input into that particular feature or that particular PBI. And then the PBI goes into development, then testing, and then deployment. So that's a high-level overview of what we do at the product management level.
Great. Thanks a lot, Russell. So we have I have up here a sort of a sample backlog that we've used for Teleios Code Jam. So you can see here a list of product backlog items. Also, if kind of working through that, we use TFS 2015 quite often to, we've been using it for a while actually to manage our code. It's our source control repository. Beyond that, we use the features of TFS for application lifecycle management. So you can see the PBIs or the product backlog items, and you can attach them to code you submitted. We started researching this a couple of years ago, and then this year with the release of TFS 2015, it became much more relevant to us, and we ruled it in, which is using the build management tools in TFS. That is, when you submit code to TFS, you can have it automatically via a build server compile that code and run tests to make sure things are fine. So Ryan's example was, what if you could, every time you queued a build, as in had the build server execute a build and the associated tests, you can get notifications as to whether the build was successful or not based on the result of that. Well, you get notifications about the success or not of the build. So I'm sharing my screen so you can see I've started a build here. So if I stopped screen sharing and went back to my camera, we could wait for a while and see what happens with this light. So while that's happening, let's take a look at this board a bit more. So when we first did it, I admit I'm not the best with the electrical engineering part of things. But to rescue me, I called Keisha Peters. So Keisha, can you remember when you were doing this?
That was 2 days ago. Yes, of course I remember.
Great. I was very confused by this, and I would love you to explain for the rest of us what's going on with this board.
Okay, so basically, the board takes power, right? And Owen basically programs the board. So Owen, I'd like you to hold the board up, please.
Sure.
Thank you. So we have the LED, and the LED has 4 pins. Turn it to the side, please. Vanna white.
Sure, here I am.
Hand model.
Next way. There you go.
Next way, thank you. And you see the pins.
There you go.
So in this order, I'm waiting for the camera to focus. So there are 4 pins on the LED. One is for red, one is for brown, one is for blue and green, right?
Yes.
So what we did, we attached, so the board itself has input-output pins. So you program the pins to input or output as Owen was showing in code. So we used pins. Well, I guess to understand what is going on with the Spark core, you need to see something called a pin diagram, which explains the function of each of the pins. So Spark core takes 3.3 volts of current. All the pins let out that amount of current. Oh, when the light came on.
Oh, wow.
Light before I continue?
Sure. So it could be electricity, or it could be our build server saying, yo, things were fine. So if you look here, you can see this build succeeded. So we got that green light. Keisha, you go ahead and continue explaining, and I'll check in a build and I know it failed. I know it failed, sorry.
Okay. I need to see the
stop sharing.
Right. Okay, so we connect the red to the input output pin called AO. We connected the blue and green to D1 and D2, D0 and D1 respectively, right?
Yes.
So the LED pin, the LED itself takes a current to come on. So the red pin takes 2 volts, but the Spark core is given off 3.3 volts. So we had to use a resistor to step down the voltage to actually send the proper amount of current for the red pin to light. Russell's telling me something about electricity.
I think Russell is just excited about electricity and the fact that it works.
Okay, and you have to connect the the blue pin to the
Yeah.
to the other input output pins, and that's how
So Keisha,
a very
I can just
simple
pause
circuit.
you to kind
Sure.
of show it here, right?
Yeah.
So on the board it says ground. So this wire here is
Right.
connected
Connected to the
to
ground
the
of the
ground of the LED, and
right.
the 0 and the 1 are connected to red and blue, um, based on our configuration. And finally, A1 is it A0 is connected to the red pin. Yeah.
Yes, it is. Sorry, I got this distracted.
Great.
And that's it. A very very simple circuit using sparkle and LED.
Right. So we have Ryan saying amp it up, Keisha, and I just wanted to let everyone hear Ryan's contributions. So the build I just submitted, as I mentioned, you can automatically have Visual Studio Team Services build your solution upon check-in. So this is demonstrating Visual Studio Team Services, which is a cloud-based solution. Teleios, we use Team Foundation Server 2015, so it's online. We use it on-prem. But we have automated build configuration enabled. So this is since we've been using it, it's been really good to know what's going on with with our builds automatically, as opposed to waiting for someone to pull code down and see what happened. Right. So thanks, Keisha, for that demonstration. Heading over to our build server now. We will see that the build failed. Now, part of what we do in Power Hour is kind of, we start off by demonstrating stuff we've worked on and stuff that we've built. I just ran this build and it didn't do what I wanted to do. So I guess we can use this session to figure out what happened. That light came on because I tested to see it was coming on, but the build failed and it didn't get to my next step in the script. So if you look at our build sequence here, so if the build works, it'll be green. And it worked just a while back. But, and so let me draw on my Teleios engineers in particular to help me figure out, well, what happened? It didn't do what I expected it to do, which is invoke my script when after the build is done. So I can walk through these steps. There's initialize agent, get sources, and this is based on this build definition. So you can see it failed here. I can say edit. So you can see run NuGet, build the solution, run tests, and then run the script. Maybe someone could tell you what I suspect. This doesn't run. This script won't run if a previous step has failed. Anybody want to back me up or tell me that's wrong?
Do you test pass?
Well, it didn't get a testing. I made it fail at compilation.
Mm.
It has a continue on error. Let's see. I like the continue error option, Peter. That may be it. I want to try that. Yeah, sounds good. So I'll save that. I'll head over to, I can take Q new build right here. and perhaps see if that works. So let me turn off that light. So the light is off. And let's see, so it's looking for a hosted agent. So mind you, this is running in the cloud. So it's taking advantage of the services that the Visual Studio team have provided online. Let me take a look at that definition one more time. Loading up these options. Oh, didn't it save it? Continue on. Oh, so I have build being continue on error, but not the others. So that could be a problem. All right, so let's take a look at our test. I like this. This reminds me of the first one and the second one. We had a thing that worked, and then we had to reach out into our skill bag to find out what's going on. That's making the thing not work. So we can see it's in the build step right now. No, it's in the test assembly step. Ah, look, I think it ran. Ah, success. Thank you very much, Peter. So let me stop screen sharing. And you can see that flashing red light. All right, I think that was it. Good job, Peter. So we see today how we could wire up a Spark core such that that light could come on and off based on the results of builds in Team Foundation services or Team Foundation server. So guys, you think we should roll this out for a solution for QuickWorks?
For sure.
Right, Ryan Shripad commented, we need a bigger light. Apart from that, anybody saw any issues with? So noted on the LED scroller, guys, that also failed, that says we failed the build. I had the idea of just indicating what failed so you can have a number of applications attached to this light. So you could walk around the room and know, oh, the room is in a state of success or state of failure. Wonderful things. There's one other thing I wanted to mention. Let me go back to let me go back to the code, back to PowerShell. So I'm going to show you something that you could take advantage of if you're so willing. Right. So you should be seeing my screen. Literally, how I got this to run, and this is what Particle provides. They give you a device ID and an access token, which you should be seeing. Using that device ID and access token, I literally just invoked a REST method, posting to that URI, and the body being args green. Which means, well, anybody could do this. Anybody could just write that code and make it light up or change the light around. Anybody want to try quick? Well, you could go ahead if you do all know. Anyway, so of course, that's not to me, the most secure way of doing this, particularly with that access token being embedded in the URL. So I was thinking, how could we fix that? Anybody have ideas on what could be done instead of that?
hide the post behind another web service.
Yeah, yeah, I like that. Keisha, Claire, what do you think?
What Akash said.
Yeah, in some of the readings I've done, this is a good um use case for something like service bus, where we allow people to post to service bus, and then from service bus we this is Azure Service Bus, guys. From service bus we invoke the relevant URIs that get this light on or off. So I guess that's it for today. If there are no more questions, thank you for joining us at Teleios Power Hour Live. Oh, I see, Ryan, you just tried it. You may have used a token, but did you post with args equal green or args equal red in the body? There you go. All right, so we'll spend some more time playing with this, and I hope you, our viewers, get time to play with solutions like this as well and make them useful in your own context. Take care. Cheers.